Let's see if we can figure out if a function is even, odd, or neither. First, I'm going to show you the graph, and let's see if we can find some pattern. Okay, we've got negative 5x to the power 9 plus 5x to the power 5. Interesting graph here. Let me see if I can get closer, and then we want to go ahead and zoom in. And if you look at this point right here, and then we're going to draw a line through the origin until it intersects with the graph on the other side. As you can see, whatever point we have over here, it's going to also appear on the other side if we switch the signs, right? So this point has coordinates x, y, but this point has coordinates negative x, negative y, right? And yet it stays on the graph. What is happening with functions that are called odd? They are going to be symmetric with respect to the origin. How do we tell if we don't see the graph? If we only see the formula, how can we figure out that this function is odd? Now, here's a hint for you guys. Look at the powers. If the powers are odd, so remember, odd numbers are like 1, 3, 5, 7, and 9, so on. Then if they're all odd, then the whole thing is odd. But what is the definition of odd, and how do you formally show that? Okay, so here's what you have to do. You have to replace x with negative x and see what that's going to do to your function. Okay, so instead of x, I am plugging in negative x, okay? And then what happens when you multiply negative x by itself odd number of times? Well, you know how minus and minus cancel out and become a plus, but here we have an odd number of these minuses. So one of them is going to stay, and that's going to turn this minus into a plus. So we'll have 5x to the power 9. Now this one will turn the plus to a minus, because again, we are multiplying by itself 5 times, which is odd. Now, what we want to do is compare what we see right here with what we see over here. Do you see that the signs are flipped? They're exactly the opposite. So here's what happens with odd functions. F of negative x is going to be negative f of x. That's what will happen, is this negative is going to jump from over here and it'll jump to the front. That's when we call the function odd. Okay. Now let's look at this other example. All right, so let's see, negative 7 x to the power 10 plus x to the power 6 plus 3. Okay, now what is happening here is, let's again try to zoom in closer, maybe take a point. Okay, so let me go over here and take this point, and what we'll do is this time we're going to draw a line that's parallel to the x-axis, and then that's going to be over here. So we're going to wind up over here on the other side. So my line went a little bit away. But anyway, all right. So what is the difference between these 2 points? Okay, so this one is going to have some x and y coordinates, but this other one, the x got flipped, but the y stays the same. This is what happens with even functions. When you plug in negative x instead of x, the y will stay the same. The function is not going to change at all. Using the graph, even function, you can tell it's even if it is symmetric over the y-axis, okay? Unlike the odd, which was symmetric around the origin. Now, what if you don't see a graph? How do you tell, looking at this thing, that it's going to be even? Well, do you see that the powers are even? Now, you may be wondering, what about 3? But 3 doesn't have an x, so obviously it's not going to change if you plug in negative x, okay? Also, you can think of it as x to the power 0 if you want to, because anything to the power 0 is 1, and 0, you can say that that's also even. Okay, but let's see how to formally show that. If I were to plug in negative x for x, what will happen? Instead of x, I'm now plugging in negative x and putting it in parentheses. Well, because I'm multiplying negative x by itself 10 times, and then that's even number of times, all the negatives are going to cancel. And so I get negative 7x to the power 10. This one is going to cancel plus x to the power 6 and then plus 3. Now, compare what you saw right here with what you see over here. Guess what? They are exactly the same. And that's what happens with even functions. They are symmetric over the y-axis, and if you plug in negative x, the function doesn't change. Now, let's see if we can figure out what's going on with this other one. This one is a combination. One power is odd and one power is even. This is not going to be symmetric. It's pretty clear there's no symmetry, right? It's not going to be symmetric over the y-axis. It's not going to be symmetric over the origin. It is not symmetric at all. And so this is neither. And you can tell that by the powers. This one is odd. This one is even. It's a combination, so it'll be neither.